Okay, guys, section 10.2, it says solving inequalities, and we talked about some of this yesterday. I just wanted to sort of give you a brief intro or remind you again of what we did last year with solving inequalities. An inequality is an equation, but instead of having an equal sign, it has this inequality sign. Okay? Less than, or greater than, or less than or equal to, okay? We'll call those inequalities. And we solve them the exact same way that we would solve this if it had an equal sign between them. Right? We'd get the variables together. We'd minus 4x from both sides. Right? And get 2x minus 3 is equal to 7. Then we'd add 3 to both sides. We get 2x is equal to 10. Divide by 2. And we get x is equal to 5. Okay? We do this exact same way as if it had an equal sign. But there is one exception. Okay? And the one exception is if we are solving, if in the process of solving, we have to multiply or divide both sides by a negative. If we, for instance, negative 3x is equal to 9. Is less than or equal to 9. To solve this, I've got to get rid of the negative 3. How would I get rid of the negative 3? Troy? I would divide both sides by negative 3. I'm dividing both sides by a negative. If I do that, what do I have to do, Gordy? I have to flip the direction of the inequality so that it points in the opposite direction. I'm going to close this door so we don't hear all the first grade.
Is it because two negatives make a positive?
I'm sorry?
Is it because two negatives make a positive?
No, hang on to that question, Troy. Okay, so the one exception is if we multiply or divide on both sides, then we flip the inequality. So let's look at this example real quick. Okay? This example asks us, let's see if I can, there we go. Let me scoot that down just a little bit. It says solve this inequality and then graph its solution set. So we're going to have some solution stuff, right? We're going to add, subtract, and all that stuff. And then we're also going to have a number line where we graph the solution set. Okay? So let's look at this. Just like I said before, we solve it just like an equation. The first thing I'm going to do is subtract 4x from both sides, right, to get the variable together. So now I have 2x minus 3 is less than 7. Then I'm going to add 3 to both sides, and I'm going to get that 2x is less than 10. Then I'm going to divide both sides by 2. Okay, now I'm dividing both sides. Is it by a negative?
No.
No, so the inequality stays the same. And I'm just going to get that x is less than 5. Now, the second part of this says to graph the solution set. All right, here's my number line. What's the critical number for this inequality? What's the critical number, Austin? 5. So the number in the middle is going to be 5. I'm going to put one on either side, make this 4, and make this 6, which you should do, and you remember from last year. When I only have one critical number, I put some on either side just to give some scale to my graph. I'm going to put a circle around the 5. Should I color in this circle? Should I color in this circle, Benny?
Yeah.
No.
No.
And the reason I shouldn't is because it cannot equal 5. It has to be less than 5. So I can't color in the circle that represents 5. I just have to start on the outside of the circle and shade to the less than side. Okay? So it can be 4.99999999999 on forever infinitum. But it can't be 5. Okay? All right. Now, Troy, you asked a question, and I'm running into the red here for just a moment. Imagine this. Do you agree that if I have that negative 3 is less than 2? Do you agree that negative 3 is less than 2? Okay. What if I multiply both sides by a negative 1? I'm multiplying by a negative, right? So now I am changing the absolute value. I'm saying that this over here now is going to be 3. I'm not changing the absolute value. I'm in fact changing its sign. Okay? And then over here I get negative 2. Is this true? 3 is less than negative 2? No. I've changed those signs. So I need to flip this sign in order to keep that statement true. Yeah? All right. Fair enough. Good job, guys. Let's look at the next example.